Good afternoon, Jan.
Hi, Michael.
Looks like, yeah, it looks like my camera has been usurped.
I hear you, but I don't see you.
Yep. Yeah, it's OBS taking over the camera for me. So let me turn that off, and then toggle that on. There I am. Hey, can do that without even shutting things down.
Great.
Yeah. So your video got all wonky, but it'll clear up soon, I'm sure.
Um, Okay.
Okay. All right, I
And my
think everything
videos.
is working.
Okay.
Yeah.
So there was some hidden code in Jinaga that did all the work for me.
Yes, yes.
So you wrote me that mail, and I just that day I discovered that routine.
Uh-huh.
I said, what is this? But it was not used, no reference at all. Um,
Yep,
and
yep. I think I translated it from the JavaScript version, and I
Mhm.
think I did so without tests, maybe. Um, that's why there were no references,
Mhm.
which is very dangerous. Why would I do something like that?
But it did work because the only bugs were on my side. Some collections that I didn't initialize. Um, Again, a collection to which I added an element, but it was an immutable collection, so I didn't assign it to a new variable. Uh, the usual stuff.
Oh, yes, yeah, that's a common one. I'm
Yeah,
going to hop out of the channel and back in, see if that clears up the video real quick.
still having problems with the video.
Yeah. Yeah, so let me disconnect and I'll reconnect. Oh, wait, you just popped in. All right. I just hovered over the disconnect button, and that was like, that was enough.
Okay,
Thank
good.
you.
So that means that Jinaga.net is working, I
Yeah,
think.
yeah. So now it's ready to demonstrate to to the improving you class. It's all done.
Yeah, I haven't I haven't cleaned up. I didn't do any further tests. Um, but so in fact, Jinaga.net can connect to a replicator, I assume. Didn't try
Oh
it.
yes, yes, yeah, it can.
Um, which means that it should fully work.
Yeah, I think so. I yeah, which is yeah, that is kind of surprising to think. Yeah, it's been kind of nascent, sitting in the background for a little while, informing
Mhm.
the design of Janaga.js. Um, but no, actually, it's been slowly growing, and now this feature is in there. It should be, beginning to end a good experience. Um, yeah, yeah, I think I've even got the hook in there for you to put an authentication header on the requests. So yeah, yeah. Now it's just a matter of trying it out with Blazor and with Maui. I think
Mhm.
I'll start with Maui. Um, that's the one that I teased in the improving you abstract.
Mhm.
Um, actually, that's even the name of the course. Janaga, your Maui backend.
Okay.
Yeah. So
And I think that's the one I'm also going to use
yeah,
for DWS. Um, so time for me to start looking into that.
yeah, yeah, and have to figure out all the patterns for how do we connect a Maui user interface to a Janaga watch, so that do we go through Assisticant to do that? Do we go straight to the
Yeah.
Maui interface? You know,
The good old assistant.
yep, yep, it's still there, but yeah, haven't updated it to make sure that it takes full advantage of Maui or works well with it. So there may even be some updates necessary there. So we shall see.
Yeah. I have to start discovering Maui then,
Mm-hmm.
because that's going to be something quite new for me.
Yes. Yeah. Yeah. It's yeah. I'm familiar with Xamarin. I've been following that journey for a while, and so Maui is in one sense just the evolution of Xamarin. So so it should be pretty familiar. Um, but yeah, I haven't built my first Maui app either. So I promised an Improving You where we build a Maui app together, but I guess I have to do that myself first.
But it should be stable enough normally.
Yeah, yeah. Yeah, I'm not worried about Maui being unstable. Yeah, so it's just my own familiarity with it. It's how well does Janaga.net actually work with it? How well does Assistant work with it? Do I even for the Improving You probably won't bring Assistant in, but that's something I've been thinking more and more about when talking to people about application development is the different types of state. So the thing that Janaga is really designed for is the persistent state. So this is the state that represents the actual stuff of the application.
The database.
Yeah. Yeah. So if you're making API calls to a backend database, you're dealing with persistent state. So it's and so like I'm thinking in terms of React, a lot of times without Janaga, people will use something like Redux or Mobx state tree to store their persistent state. But there's not enough, I think, discussion around the fact that there are other kinds of state and they should be treated differently. So the other two kinds that I think of are the transient state. So if you are filling in a form, then it's keeping that that state of just your work in the form, but it's not persisted yet because you haven't made an API call, you haven't saved it to a database. And a lot of people in React will still put that in the Redux store or in the Mobx store. And I think that's a mistake. I think it needs to be brought closer. It needs to be part of the component. And then the third kind is navigation state. And usually there's a navigation component that keeps its own state, so you don't think about it too much. But sometimes the navigation state and the transient state kind of intermingle. So like I'm on this page and I'm filling in this form and then I navigate away and I come back, and so I have to, or maybe I navigate to a different place, but of the same form, just in a different entity. So want to keep those two, and it's related to navigation. So that gets kind of weird too.
But so the navigation state is just where are you in the collection of forms?
Yeah.
And the transient state is just the data that you have entered into the form but not saved yet to the database.
Yeah. 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 And I think they deserve their own, each one deserves its own way of working with it. Yeah, and people don't often think about them as different forms of state, and they kind of mix things up. So when I think about Assistant, it's especially combined with Janaga. I think Assistant is really good for the transient state, and Janaga, of course, designed for the persistent state. So so I'm not certain that it's necessary to put an Assistant view model in between. So it could be that you use j.watch in order to to listen for changes to a projection, and then you update a view model with that projection, and then that view model is controlled with Assistant so that you can then bind to it on the other side. But because you have so much control over your projection, you could just bind directly to the output of the projection. Um, that's what I've been doing in React. But then again, um, when you have React managing changes for you, you don't need something like a System. So I don't know. Yeah, it'll be interesting to see once I get in there. What are the patterns that emerge?
Mm. Now, one of the things that I still find a little bit troublesome sometimes is in that transient state, you enter data.
Mm-hmm.
The moment you save it to your database, you're going to validate the data, but you can also save it temporarily.
Mm-hmm.
You just want to save a half-filled form,
Yeah.
which you want to continue afterwards. So you need to save it to the database, but you cannot run the validation on it
Mm-hmm.
because it's not valid data. It's all filled.
Yeah. Yeah.
So there you have like a transient state, which you're gonna save persistent, and your validation cannot run because otherwise you cannot save it.
Yeah. So I wonder if in those situations it might be better to think about that as workflow, and workflow happens completely inside of persistent state. So you fill out a form and you persist it. It's persistent, and then there's another workflow where you say, all right, this is done. I'm going to submit it, and that does the validation, and then creates another workflow step that says, okay, this form has been
Validated.
validated. Yeah.
Okay.
Yeah, because it might be. Yeah, I'm thinking about the application that I worked on, starting the beginning of 2020. This was um, for portability of medical licenses across state lines. Um,
Mm-hmm.
so we were we collected information about the physician or the nurse or physician assistant. So they filled out a form to kind of identify themselves. They could leave that form and come back to it. So it was persisted, but then they said, okay, go ahead and look up my license. So they hit a submit button, and so it was already persisted, but then we created another fact that says, all right, this form has been submitted. Um, and then there was a backend process that looked for the submission, but not didn't look for the original form. So once the submission
Okay.
is created,
Yeah.
then it did its backend work. So validation might actually even be a backend asynchronous process. Like in this case, it had to call an API and it had to do a bunch of work in the backend.
Mm-hmm. The moment that you had the submission flag, then you did the validation.
Yeah.
Okay.
Yeah. Yeah. So that might be a pattern to explore.
Yeah. Sometimes that I got into regularly.
Mm-hmm.
I say, what do I? It's a little bit a funny situation where you store things which are not valid.
Yeah. Yeah. Yeah, that is true. But people need to be able to get back to their work. They need to save it.
Yeah.
So
Mm-hmm.
nice.
And because it even goes further. Sometimes you say, okay, I don't have the right data type.
Mm-hmm.
I just have some information. It's not correct. I know. I want to store it temporarily, and I will get back to the right data type the moment that I validate everything.
Yeah, yeah. That
Um,
that reminds me of some advice that I heard. I think I'll look it up and see if I can drop a link. But the advice was parse, don't validate. And the meaning behind that is that you take input, which, as you were just saying, is in a different data type than what you ultimately want, and then you write a function that converts that input into the data type that you really want, and that's parsing.
yeah.
Validation would be a function that takes a data type and then returns the same one, and just says yes,
Mm-hmm.
I believe this is valid. But the the reason that you would want to parse rather than validate is that now you can enlist the compiler's help. So if the compiler sees that data type, it knows that it is true and valid. Whereas if it's the same data type before and after validation, then the compiler doesn't know the difference between the two. And you can use things like nullable fields, or like a string field to represent a phone number. But anybody can put anything into a string field. But then you go through the parse step, and now you can have a stronger data type that says this is a phone number. And so I know that if you were to execute the right function on it, you would be able to make a phone ring. So it's validated to that degree.
That was, for example, a phone number could be a case where you have the phone number, but you don't have the country code for the moment.
Yeah.
You still want to store it because you don't want to lose it, but it's not valid because the country code is missing.
Yeah. Yeah. So in that case, those would be two different data types. So then now, bringing back the persistence argument, if you were to persist the unvalidated data, then you would persist it with one data type and then submit it. It does the validation. It produces a different data type, and you record that information in the fax.
You would store everything persisted as a string, everything, and then afterwards go and get the right data types.
Yep. Yeah, I've often argued that things like SQL injection attacks or cross-site scripting attacks, they aren't about cleansing your input like people always advise, but instead they are about parsing. So they're about data types. So a SQL injection attack is just because you are treating a string as if it were SQL, but string and SQL are two different data types, and the difference between the two is a parser. So you follow parse, don't validate. You have strong data types for each thing, and you end up being able to completely eliminate the possibility of certain kinds of attacks.
You say you just entered SQL, so forget it. I don't store it.
Yeah. Cool. Well, do you have some green tests to demonstrate on the stream?
I can show them. Let me see.
It's exciting news. We have to show it.
Actually, the thing is now that it's working. The question is, what are we gonna do with it?
Yeah. Yeah.
Right,
That's always the that pause in the whole TDD process. It's like, okay, I've written a test. All right, I have a thing to do. I'm going to make the test pass. Test passes. I can't think of a new test. Now I have to sit back and think.
But just up to now, it was always about getting the thing work. But now that it works, right, let me first get the Explorer so that I can delete the database, update the directory, go to local, and then delete my Jinaga database. Okay, so this one, you can see the screen.
Yes,
it's
I can.
Readable.
It is.
So we have the query tests here. Yeah, I saw that this one, the constructor with the output parameter. I didn't upload that change. I don't know, at a certain moment I did, but you didn't accept it, I think. The only purpose of this is to be able to do a console output, which is shown here inside the summary field. And I think where am I using this? Here, for example. So you can just say output.writeLine flight with the flight fact, and then that information will get into here, standard
Nice.
output.
Yeah, so much
So,
better than using the debugger. I love it.
well, sometimes it's useful.
Yeah.
But so we are working with the SQLite Store and with the local network for this moment. So I deleted the database, which means that it will create a new database every time. Let's just run them all, see which ones fail. But if they fail, that's probably because there is an interaction between the tests. And then I delete the database again and run the red ones.
Okay, so you're manually deleting the database between runs of individuals.
Yeah.
Okay. Yeah.
We are lucky there are only 2 of them failing. So the last one here and this one. So if I just delete my database, because this one is failing because you see expected flight to contain a single, but it found a lot of things. So I deleted my database. I just run this one again, and it's green. Then we go to the last one. I delete the database again. I run the last one, and it's green again.
Yeah.
So now all the tests are passing.
Yeah.
Perhaps I should just delete the database here automatically.
Yeah, I think so. And there's another alternative to deleting the database that we could also explore. So the root of all of these facts is the airline, and so if we randomly generated an airline ID for each test run, then the test would still end up being independent even without deleting the database.
Yeah. So just this IE, change it in whatever.
Yeah, exactly.
A random number. Okay. But don't you feel it's more clean if we just in the constructor?
Yeah,
just
I think it is.
Database?
Yeah, that probably is more clean.
And then we are sure that the database is well created also.
Yeah, very true.
Okay. I will do that, and then I still have to move some. Here what do we do? Because initially it was the Jinaga test.create to create the memory test. I changed it for this one to that. Do you prefer that I just copy all the routines into a SQLite test file?
I think what we want to do is we definitely want to have some factory method, This is interesting. So we've got Jinaga client.create, I think is what we call it. If you're writing an application, and so you should be able to pass in all the parameters to the factory, and then it knows what to do with those parameters in order to create, for example, the SQLite Store. Problem is that SQLite Store is in a different assembly, so that means the factory would need to be in that assembly. So it couldn't just be Jinaga client.create.
The question is also, it would be nice if you could just say, I run all the tests in Jinaga tests, and it tests the memory store and SQLite database as well.
Oh, I see what you mean. Yeah.
But is that necessary?
Interesting. Yeah, I kind of like that. On the other hand, I do also like the fact that when you're looking at a specific test, you know specifically, I'm testing the database or I'm testing the memory store. So it might. In this case, the way that you got to these tests is that you copied some some memory tests. But then as we create new tests, it's so that we can test new features of the SQLite store or of
Because here it's not a copy. It's just this that I changed.
Mm-hmm.
So either it uses jinaga-test.create, where the J points at the memory store, or I use the new Jinaga with the SQLite store. So the tests are still the same.
Yeah.
But so it might perhaps be interesting to have a file which is called query test memory store and query test SQLite store, so that they are completely independent and just a copy of each other.
Mm-hmm. Oh, okay, yeah, just a copy of each other. I thought you were actually going for some reuse. So you write the test once, and then you somehow say run this with memory, run this with SQLite, which
That's
I
what we are
think.
doing now.
Yeah, I think. Yeah. So what we're doing now is actually a copy of the code, which means that the code could evolve independently, which is probably not a bad thing. Yeah. I think that's. I think that is the right plan.
Okay.
Yeah. The alternative that I was thinking is that if the tests were in a base class, then a derived class could provide a different Janaga instance to its base class. But tests in a base class seem a little weird. Yeah. So no, I like this. I like the copy.
Let's
They
keep
might
it
be
stupid simple.
yeah, and they might be the same now, but that's no guarantee that we'll always want the tests to be the same.
Okay. We'll just make it like a copy, and then for the structure of the solution. So at this moment we have in the core we have Jinaga. We have the SQLite store. We have the tests, but so these are not the tests that we are talking about. These were the
Yeah, actually, that's another reason right there that we want to have a copy, is that the SQLite store tests are in that assembly. They have a dependency on SQLite store, but the in-memory tests are just in Jinaga.test.
Because this was what. Yeah, these were other tests that you made.
Yes.
Yeah, for the generator.
Yes.
Yeah. But so we should add the query tests here as well, so that all the tests for SQLite are inside this its own assembly.
Yes. Yeah. Where are the query tests right now are in Jinaga test. Okay. Yeah, which means now Jinaga test has a dependency on Jinaga SQLite. And so if you move those tests into the SQLite tests assembly, then you can eliminate that dependency.
Yeah, they are here, query tests. They are in Jinaga test.
Yep, move it. I like that.
Okay. And what are these unit tests? Okay, that's just the simulated.
Yeah, Jinaga unit test is for other people to use to make unit tests, versus Jinaga test is for our tests. Yep.
Okay. And then we had the graphics, which is good. Okay. So we just to move out the tests in here, move them out and put them in the SQLite.
Yep.
Test. Okay, we can handle that.
Excellent. Yeah, that's going to be good. Okay. Yeah. And then I'm still thinking about the factory function. If I like in Jinaga.js, there's Jinaga server.create, and then you pass in parameters like the URLs for for your upstream replicator, um, uh, your Postgres connection string, all the stuff that Janaga server needs, and then it builds the graph. Um, so so it might be that we've got a factory function in um, Janaga store SQLite um, that builds that SQLite dependency, which I think that's probably the right solution for now. I'm thinking about how we might add other capabilities, like when we're targeting mobile. There were probably some extra things that we want to add for, like push notifications that are just available on mobile. But SQLite is not strictly mobile. It can be used for desktop, but we would have different support for desktop. So for right now, it seems like it's okay to put the factory method in Janaga Store SQLite, knowing that if we then have another assembly for mobile, that assembly will take a dependency on Janaga Store SQLite, and maybe we can just move the factory method. That way we can bring some mobile stuff into the graph.
Okay. But so for the moment, put that factory method into SQLite.
Yeah.
Anyway, I would like to use SQLite for Windows applications as well, for simple desk applications.
Yeah, indeed.
Because it's so easy. It comes with the application, and you don't have to worry about it.
Yeah. And then for those, you don't want to take any dependencies on anything that might be mobile or specifically iOS or Android. So yeah. Then I think it wouldn't be a matter of moving the factory method eventually when we create those assemblies, but instead making a different factory method for the more specific one. So create the factory method here and name it something very local, like Janaga SQLite.create, and then we'll create an additional factory method for those others that it is even more specific, but takes a dependency on SQLite, and so you can pass in a SQLite connection. Well, path, I guess, is the parameter.
And we will still have to see whether SQLite in this standard configuration will work as well on Android as on iOS as on Windows.
Yeah.
Because I don't remember exactly, but I thought that Android has SQLite built in. So you can add your own version if you want to. And that was what I was doing here. But with iOS, I don't remember. You might be forced to use the version which is in iOS built in.
Interesting.
I'm not sure anymore. I will find out when I try it.
Okay. Yeah.
And on Windows, everything should run.
Yes, we might, if that's the case, then it might be. So this is the one that works on Windows. It's just use SQLite. There's a file, but yeah, it might actually be that for the Android and iOS assemblies, we might actually have different assemblies, and they know exactly the restrictions on that platform. But then they can reuse the SQL generators and all the stuff in this assembly.
Because I'm not sure what Maui is going to do for these databases. Is Maui just going to be transparent, or is it interfering with the databases? I've no idea.
Yeah, it'd be nice if it was transparent, but yeah, that is what we need to figure out. And there's not much time. Got to get that improving you.
Because so far the SQLite implementation is working quite well now. I haven't tested a lot, but with these few tests, the transactions seem to be working fine. The storage is fine. Everything is fine. We will get some trouble, I'm
Mm-hmm.
sure, but not yet.
Yeah. Well, very
Okay.
nice. Okay, well, I've got something else to share.
Now let's stop this sharing, then stop streaming. Okay.
Okay. And then we have... All right. Oops. Now I've lost our pictures. There we go. All right. Yeah, so this project is called Colab. It's an example that that I started putting together, and it is in the Janaga organization. So git remote-v. It's in GitHub Janaga/Colab. And yeah, this is when we started with Create React App, getting that working, and then hooking it up to the Replicator as a service. So we've got this pattern in here where in .env we create Janaga Replicator URL environment variable, and give it the address of a URL. But this is the one that we want to use for production. For local development, we've got .env.local, and then in here we put our own development replicator. So keep that one all to ourselves. That way each developer has their own replicator. They're not stepping on each other's data. So created this to start working on working with replicators and seeing this development pattern emerge. So now that that the replicator as a service is authenticating with Apple, and it's using that token, then now the next step is to authorize. Actually, I don't think I demonstrated that it's actually using the token on the stream. Maybe I'll go back and do that real quick. But so that's authentication. Now authorization, we have like in this one, I did a vertical breakdown of the project. So so all of the stuff to do with projects. So any view models, any views components, in this case being React, any models, they all related to projects all live inside of here. So here we've got the Colab project and the project name, an invitation for others to join your project and collaborate. So that's all in here. But then there's also the where's the users? Well, let's take a look inside a model. Okay.
So this Colab project, what is it doing exactly?
Yeah, this is to demonstrate the application pattern of collaborative sharing. So so the idea is going to be that you've got a project, and then as a user you can create a project, give it a name, and then invite others to join the project. And then there will be another, actually it's already here, yeah, tasks. So there's another portion of the model that's adding tasks to the project, editing their description, and then this will grow to be assigning them, having some kind of workflow about moving them from one state to another. So sort of like a really simple workflow kind of thing. So like like a really simplified Jira or a Trello, that kind of thing.
Yeah.
So I think that is a good application template of this is a useful kind of application that you could build with Janaga, and then these are how all the pieces fit together.
A to-do list with workflow.
Yeah. Yeah. So you'll have different kinds of workflow effects that attach to tasks and move them from one place to the other. So, which, by the way, started diagramming the second edition of the book. So, so I've made some changes to the outline, and application templates is one of the things that I want to add. I don't think that the patterns chapter is really doing its job, so I'm kind of splitting that up, moving that content into different places and turning it from patterns into more narrative. So it kind of flows better with the book instead of just like, oh, let's tell a story and then patterns and then keep telling the story. And so what I want to replace that with is, instead of each of these small individual patterns, it'll be like, let's describe a collaborative application. This is how that all fits together. And then show other application templates. So so rather than collaborative projects, maybe it's a part public, part private application, like a blog, where some parts of it you can see without being logged in. Other parts you have to log in to see. So yeah, a few different application templates like that, maybe 3. But yeah, this is an exploration of one of those application templates. So we've got projects, we've got tasks, and then here we've got users. So we've got the Colab username is related to the Janaga user, and so this one actually comes from the library. So this one is inside of Janaga, but this is janaga.user. It's not showing what the type actually gets set to inside of the compiled code, but it's in there. This gets set to janaga.user. So we've got that user model. So we've got 3 different files, and as your application grows, you're going to have more files that are defining different parts of the model. And so we want to bring those together. So here is model index.ts. So that means you can just import from model and you get this. And here we've got the model. So that's composing the user model, the project model, and the task model. So each one of these is their own little, for this type, these are the predecessors kind of models. And then the next thing that you want to compose are the authorization rules and the distribution rules. But here we are on the client. We want to enforce those rules in the replicator. So how do we do that? So if I go back to project, I've got the project authorization. So this sets up the authorization rules. So for the type project, the project creator is authorized to create it. For the project name, the project creator is authorized to change the name, and also any invited users. So I've found with the specification syntax, it was possible to just extract function and create a function that gives you a specification. That way you could reuse it. So the invited users are allowed to edit the project name, and they're allowed to invite other users. So we've got that set up. And of course the creator can invite users. So that ended up being nice and compact. And now I want to take these authorization rules and make them available and enforce them in the replicator as a service. So if I were writing code and compiling that code and then putting it into a container and running it on the cloud, then I could do Janaga server dot create and pass in this function, and it would enforce those inside of that server. But I'm not using Janaga server dot create. I'm not deploying it to a container. I've got Replicator as a service. So that means I need to take these authorization rules, package them up in some way, and then send them off to the portal, and then have it upload them into the Replicator as a service. So the way that I'm doing that is I've got this output authorization. So let's compose all of our authorization rules, and I might actually move this to model. In fact, that sounds like the right place for it to be. Let me move this in here. So it really should be there. So bring in the authorization rules and references to all of these things. Oops. You can find it. So import user authorization. That comes from user. Can you find the others now? Yeah, that comes from projects. And that one comes from tasks. Okay, good. Okay, so we've got that exported, and now this looks a bit better because we just have that and we don't have any of these dependencies. So they all go away. Okay. All right, so the model describes, here's the model. It's composed of these different parts of the model. Here's the authorization rules. It's composed of all of these individual authorization rules. So here's how we authorize tasks. They have access to, or the invited users can create tasks as well and edit their descriptions. And invited users is exported from here, so I can reuse it everywhere. And I bring that all together inside of the model. And so the model composes all those authorization rules. And now inside of output authorization, I just called this function from Janaga, describe authorization rules, give it the model and the authorization rules function, and then log it to the console. So inside of package.json, I've added a script called deploy::authorization. And when I run the script, you can see it's going to use TypeScript compiler to compile output authorization TS into the deploy folder. And then it's going to use Node to run it. So npm run deploy authorization. Does the compile, does the run, and we get a set of authorization rules as text. So the idea is that that we're going to use curl or something like that in order to take this text and upload it to the Replicator portal. And this will now just be part of the build step. Every time you build your client application, you also generate this text, send it off to the Replicator, and it has the latest rules to enforce.
And then it will override any previous rules on the Replicator?
Yes. Yes, that is the idea. So yeah, as an individual developer, you'll want to run this and upload it to your own private replicator, test things out, and then like, okay, that's good. Pull request, get it into the main branch, and then CI/CD picks it up and pushes this up to your test replicator. and then deploys the the tests, or deploys the client application. Maybe it deploys it to a CDN if you're running a web application, and then people can just hit that CDN, and then it talks to the replicator. Replicator's already got the right rules. Then you say, okay, that's ready for production. You go to the production step in your CI/CD, and then that's just uploading these authorization rules to a different replicator, and the client output to a different CDN.
Okay.
So you get to do client-only development, not deploying a server at all. But you still have all of the protection.
It's a nice thing about the replicator.
Yep. Yes, indeed. So the curl command for this thing, in order to protect the replicator, I want to have some kind of authentication for this upload. So I'm thinking that I'll have an API key, and so if we were to go to, let me open a tab over here, go to dev.janaga.com, and we set up our replicator. So like here's the Colab replicator. Then, in addition to setting up the authentication rules and connecting it to Apple or Google or whatever, then you should also be able to set up the authorization rules. And adding this card, which doesn't work yet, but adding this card will give you an API key that you can copy and use locally in order to protect access to those authorization rules. Then you just use that API key inside of the curl command, and then only you can update your rules.
So that step you only have to do once at the moment that you install your application.
Yep.
Okay.
Yep. So you just do that and curl it. That's just part of your deployment for local development, testing, production. Just do whichever replicator, and then it's there, and it's every time somebody uses the application hitting that replicator, the replicator is enforcing these rules. It's really nice that this all serializes into a really concise, understandable language. I'm quite happy that it's not some cryptic file, but you could actually look at this and say, well, that's the rule. Any Janaga user, which by the way is kind of a funny rule that really a Janaga user should be the only user that can create the Janaga user, but you can't have an identity rule. You can't have a rule that says, who can create this fact? Well, just the owner of this fact, because the fact doesn't exist yet, and so you run that rule, and it doesn't return anything. I might make that a special case. That way, you could actually turn this into an identity specification. But honestly, it doesn't offer too much protection, because all you're doing is saying there is a user with this public key. And then it's later when you say, okay, now I want to create, right here, I want to change the username. And so now, at this point, you're proving that you are that user in order to change the name. So you wouldn't be able to go on to the next step. So just having a user with a public key out there that you can't do anything, not a big deal. And then if you were to create the user with somebody else's public key, you wouldn't be able to take over that user. That Janaga user already exists. So I don't know. It's a funny little edge case. The only reason that I could think to support the identity specification would be just so that I wouldn't have to explain to people that it's okay. It's like, okay, I get it. Here you go, identity. Yeah.
So it's actually quite logical and quite easy.
Mm-hmm. Yep. And I didn't want to do anything crazy like with Entity Framework. You've got these migration bundles. So there's special code in Entity Framework to generate an executable that just deploys migrations. But there's already a function in Entity Framework that will deploy migrations. All you have to do is call it. So what I did before migration bundles were a thing is that I would also create a console application that just called that deploy migrations function. And then I would use that in CI/CD. Just build it, put that into a container, deploy that to, or put that into an image, deploy that to Azure, and it would create a container for that image, and then run the migrations. So here I'm just basically doing that same thing. It's like it's completely up to you to call the right function. This particular application is a React application. And I know that a React application is going to create this, no, we can't actually see it. Let me do an npm run build. So it's going to create this this build output. So it's going to have the, well, oh, okay, it's still working on, okay, it did the simple stuff. It's still working on generating the JavaScript. So the JavaScript is going to pop in here. But that's all bundled and minified. And so I say, okay, let React do the React thing. Here we go. Here we go. We've got our static folder that's got our JavaScript in it. So a bunch of bundled, minified JavaScript. But yeah, I didn't want to have to dig into that in order to find the authorization rules and do anything special. So, so I just said, whatever type of application you are creating, just do that too. So compile just this file and the things it depends upon, put that into the deploy folder and call it. So there'll be another one for distribution rules. Just compile output-distribution and then call that. Hook that into the curl command, which I think I'll just plop the curl command right here into package.json and not even give you a command line tool. Just run curl. So then I just give you instructions for how to do that yourself. Make that part of the starter kit, and it's all under your control.
No, that looks nice, and it follows a little bit the philosophy of the whole framework.
Mm-hmm.
A little bit the same syntax, a little bit of the same thinking.
Yep. Yep. I like it. Yeah, and I put the word authorization in there so that the other one can have distribution. That way you can see just at a glance if you messed up and you sent the wrong one to the wrong endpoint. Yep.
And if you mess up, it doesn't accept it.
Yeah.
If you don't put authorization there.
Yep.
Okay.
Exactly. Well, that's our progress.
Mm. That's something we can try once Maui is is up and running.
Mm-hmm.
We have some first screens with data going back and forth.
Yep. Yeah, that's there we go. That's the one. Yeah, that's going to be really good to see. So yeah, definitely have to do the same things in Janaga.net where it generates the same files. But it should be, all the same file formats and the same philosophy as well. Yeah, so I'll just have a function in .NET that you can call, and so you create your own console application and just run it.
To use Maui, it's only usable under Visual Studio, or it works under Visual Studio Code as well.
It should work under Visual Studio Code as well,
but still easier
I
under
haven't
Visual Studio.
tried it.
The full one.
Yeah, I would think so. Although with the what do they call it? Are they called bundles? But from the command line, when you create a certain kind of application, you tell it what what features, and there's like one step you do before you create the application to say install all of this stuff, and then so it knows okay, let's go get the iOS dependencies, and let's get the Android dependencies, install some simulators and all that stuff. So yeah, all of that is feasible from the command line, but just probably easier in Visual Studio.
Okay, and let's stick to Visual Studio.
Yeah.
Because the Visual Studio Code is for something so easy, it's just an editor for a simple page.
Mm-hmm.
But if it's still a little bit a mystery. Surely if you try between Windows and Linux, and it's not always completely clear for me.
Yeah. I find myself more and more in Visual Studio Code, although I do use Visual Studio when it's strictly a C# application. But yeah, even then, Visual Studio now has support for GitHub Copilot. It's just weird and slightly broken. So like, no, I've actually turned it off in Visual Studio, and I just go back to VS Code whenever I want to do some pair programming with the AI, and then now I'll switch back to Visual Studio to to manage projects and stuff, and build and debug. So yeah, it's good to have both.
Anyway, for the artificial intelligence, they're adding things every day now, I think.
Mm-hmm.
It's getting it's coming fast. So soon we will just be approving the software.
Yeah.
We will not be writing code anymore.
Yeah. Yeah, it's much easier to approve a pull request than it is to write the code. So honestly, that's the way that I feel when I'm using Copilot, is I'm just reviewing its code and then approving it. And by the way, your video is going into the matrix now, so you'll see this on the stream, but it's fine. Yeah, we I think we've got a really powerful tool now in our tool belt, and it's just going to make us faster.
All right, I'm gonna try first steps with Maui then, and Jinaga, the combination, and do that little bit cleanup that is left for us for the tests.
Very good.
And see where that gets us.
Yep. Let me know when you're done with that cleanup, and I'll get that merged in.
Okay, and then I dig up the old DWS model that we made
yes,
a couple of years ago.
Yeah.
I didn't throw it away. I still have it.
Yeah. In fact, we did explore that model, or at least part of the model in some tests, and I think even in a Polyglot notebook. So I think you even have some code that you can copy in.
But that was very limited.
Yeah.
But we did a whole model, so that should help us on the way.
Yeah, I think so.
Okay, next Thursday, I should be there, no problem.
Excellent. Well, I shall as well, so I will see you then.
Okay. Michael, See you.
Thanks, Jan.
Thanks a lot.
Bye.
Okay, bye bye.